Sir, class and
Sorry?
sir, object oriented too.
I
In
think that
Python.
has completed, right? So okay, more NumPy. We need to start NumPy. All right. So part NumPy. Python has been completed, so we'll move on to the NumPy part. I hope you can see my screen.
Yes.
Yes.
All right, so we'll see NumPy. NumPy is a library, so we are going to have a series of libraries from now on. It's NumPy, and then followed by pandas, and then matplotlib and cborn. NumPy is for numerical analysis. Numerical analysis. Whereas pandas again, the same numerical, of course, data analysis, like tabular form analysis. Matplotlib and cborn we have for visualization, for plots. So next 1 or 2 weeks, we're going to spend on this, right? So we'll start with NumPy. So usually when we have a library, we're going to import in this form. Import library name as alias. So we give some name. The reason why we give alias is if we want to give, let's take that you want to utilize a method of that library users provides. Let's take I have something called multiplication. Then we need to write the whole library name here. Instead, we can give a simple, let's take ln, and we can use this alias more frequently, right? Rather than this whole name. That's the reason we use this alias. Otherwise, we can even completely skip it. It's not must. But every library, whether it's NumPy, Pandas, Matplotlib, cPoint, it will come with its own alias name. In the sense, when we refer the documentation, they will have some name. Let's take that NumPy. NumPy has, we usually use NP. How do we know, like, why we need to give NP? So we can even give something like num. There's nothing wrong in it. But it's better to follow the documentation, right? So when you get an error, when you refer back again, Stack Overflow, Stack Exchange, wherever, so again, they're going to refer with the same code. So instead of giving your own name, better follow the same thing so that you can easily copy and paste the code, right? So this is how you can import it. There are alternative ways to import the library. Yeah.
So where can we find this one alias's name, sir?
What is that?
Alias
Okay.
name is there, na? NumPy as NP. I mean,
no, every library has their own documentation. You can see NumPy has their own documentation for it. So if you look at the documentation, somewhere or other they would have written the code NP. But for usually not to go to the documentation, but usually in pandas, it's PD. When it comes to matplotlib, PLT. When it comes to cborn, it is SNS. These are the most frequent libraries that we use, right? So if you remember this, you not remember, in fact, you will get it, you keep on doing this. So you'll get habituated to it. All right, so I'm going to focus on NumPy. So we have a library. Let's take that we are going to create a array. I'll explain what is an array. It is just like list 1, 2, 3, 4, 5. So there is no change. NP. Did I import it?
3 hours you have written. Yeah.
Right. So I'm going to, let's see, my array 1. And if you check type, it's going to be right, numpy.nd array. This one-dimensional array. So if you look at size of it, shape or whatever, yeah, shape of it, it's 5, 0. And if you look at how many dimensions it is ndim, it is 1 dimension. We can even have multi-dimensional. For example, in the same case, we can have, let's take 1, 2, 3, 4, 5, 6, right? If you look at the same values, it is, you can see that 1, 2, 3, 4, 5, 6. It is array. Shape is 2, 3. It's 2 rows. This is one row. This is one row, and this is another one row, other row. And this is column. 1, 4 is column. 2, 5 is column. 3, 6 is column. 3 columns we have. Right? That's the reason we got 3 here. So when you look at the dimension, it is 2 dimension. So if we want to calculate it manually, the way we need to calculate is whatever the first value that you see, you need to check how many open arrows, how many open square brackets. You can see there are 2 square brackets. You can say 2 dimensional. If we have one more, we can have, it was going to be 3 dimensional. 3 dimensional. You can see 1, 2, 3. In this case, the C is 1, and in this we have 2 rows and 3 columns. That is how we need to interpret. We can even have more than one value, right? Fine. So, any questions on how to create, how to declare a NumPy array? It's 1 dimension, 2 dimension, 3 dimension. How to cross check what is the shape of it and dimension and type of it? Any questions on that?
Is there I mean, what is three-dimensional like matrix? Are you telling that one?
3 dimension in the sense when we have, let's take multiple tables in it. A single array can have multiple lists, multiple tables. You just imagine a tabular data. If we have multiple tables in an array, then you can consider it as 3 dimensional, right?
Yeah. So
And
what is this array and the ND array? Is there any difference or like?
no, it's
That
a
is
NumPy array. That is how it's going to represent. So the question is why we even need more than 2 dimension. 2 dimension is tabular data table, but why we need more than 2 dimension? Just consider that this is the case, right? Or maybe this one. Look at this tree view, isn't it? So at top level, it's one level. And if you go in depth, it's going to be, see, the east area and west area is one level one dimension. And if you go in depth, there's going to refrigerator and process. This is a 2 dimension. If you go even, when you click on this tree view, it's going to be third level, third dimension. It can be even more in depth, right? The level can be even more, like 4 or 5 or 6, whatever. So we may need this data in, this is what we call as multi-dimensional data. We
so
need this
here we
kind
can
of,
recognize the folders, right? In the east area, there is subfolders. So in the matrix, how we will know that one these are the sub arrays based on the bracket itself.
no, I told you, right, that we have methods like properties like ending or shape that will give us how many dimensions it has, how many rows and columns it has. There are always, we can always use this shape or ending if you want to.
Yeah, okay, got it.
The next one is the most important one. So why do we even need NumPy array, right? So why can't we, as we can have a list, right? Just like the way we have it in Python too. So here we call it as array, and in Python we call it as list. When we have list, then what is the need of an array, right? Let me take a list itself. My list 1, 1, 2, 3, 4, 5. Okay, I'm going to take another list. My list 2, 6, 7, 8, 9, 10. So if we concatenate these two, what do you think will happen? What will be the results? We have seen this before. So what will be the output?
It will append to that list.
Append in the sense, what will be the output? Tell me the
1,
output.
2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Right, 1, 2, 3, 4, 6, 7, 8, 9, 10, right? It's going to concatenate, not adding addition literally, but it's concatenate one next to another. What if I want to add these values like corresponding index values? So 1 plus 6. What is the corresponding value for 2? It is 7, right? 2 plus 7. 3 plus 8, 4 plus 9, 5 plus 10. So 1 plus 6 is 7. 2 plus 7 is 9. 3 plus 8 is something. So we have seen list comprehensions, isn't it? So how do we I comma j? We need to zip these two lists to get I comma j. So in this, we can add these values, corresponding values. The code is complex. So in order to get the actual index values to get added, we need to apply this comprehension. So what we have done here is we have zipped this two lists so that when we loop, we get in each loop we are going to get each set of values. In the first loop, it's going to be 1 and 6. I comma j will become 1 comma 6. The next loop it's going to be 2 comma 7, 3 comma 8, 4 comma 9, 5 comma 10. When we keep on, we can keep on adding this. That creates this list. This is a list
So
comprehension.
the outer bracket is just to convert that to list, right?
Which outer bracket? This one? Yeah, yes. The outer bracket is converted into list. And in fact, we have tried the logic in this list. There are alternative ways to do that, generators and all. We'll see that later. It's not just square brackets. We can even use round brackets, but that will all together turn into a different thing. So we'll see that later. So we have something called generators, decorate. We have advanced features on top of this. So when we use round bracket, what happens is you can see generator, right? We'll see that later. So right now, just assume that we have to wrap this list comprehension, whatever the logic that we write, within square brackets, and just assume that at least now we can only write this sort of logic in square brackets. We call this as list comprehension.
If we don't write the, will we get the output, or like will there be error or something?
Without even completely skipping this, no.
Single values will come or error?
No, it's going to work. It's not going to work. Right? So any questions? I think we skipped this part back. All right. So any questions on this?
No.
All right.
No.
So next one is we are going to create NumPy array, very similar to a list. So I'm going to take the same values, but NumPy arrays we need to use array, right? And round brackets we need to provide the list. That's how we create this NumPy array. Same way, I'm going to create NumPy array 2, and we need to wrap it in np.array.
Have you imported that file already? I mean, the NumPy.
Which file? We already imported, right?
Oh.
Initially. So I have deleted that as a block. So it doesn't matter. Once we import it, that's fine. As long as you close and reopen it. Now, my array 1 plus I'm going to concatenate it. You can see that here the concatenation is not like the way it has concatenated in Python, in core Python. It has added the values literally, right? Without much effort. So do you think this code is more complex or this one is more complex?
NumPy is easy.
NumPy is quite easy. And it's not just that, we can even cross-check the time it takes to do this process compared to this process. We can use something called timeit library. The way it works is, I'm going to copy the same code to cross-check how much time this will take. So percentage timeit we need to write, and we need to write the code. Okay. So we have import timeit, and we need to use percentage timeit. Whatever the code that we want to see how much time it takes, we can copy the code over there. And it says that around on an average, and it is not just one loop, it is going to execute multiple times to give an average value. On an average, it is taking 556 nanoseconds in my machine. It may be more or less in your machine. The same thing I'm going to apply it on NumPy array and see what happens. Timeit and the code, right? So here the code is this one. It is taking 422 nanoseconds, plus or minus 6.482 nanoseconds. So which one is better?
NumPy.
NumPy or IRs? This is private, NumPy, right? So NumPy is better. So NumPy is a lot faster than Python in this particular case. We will cross-check other operations also like multiplication, subtraction, division, and all. Modulo. So let's take that same thing. I'm going to apply subtraction. I'm going to apply subtraction here too. So it is taking 548 nanoseconds for subtraction, right? In the case of NumPy array, it is 432 nanoseconds. Still, NumPy is better. Let's do it against multiplication. Just change this operation, that's all. How many seconds? Which one is faster? Still NumPy, 439 nanoseconds, whereas this one is 564 nanoseconds. Almost 100 seconds we can save for every operation, right? Same thing we can apply it on division. 638 nanoseconds. Now tell me which one is better for division, Python or NumPy?
Python.
Python is better. Why do you think Python is better? This 638 and this
Micro, right?
1.
Yeah, microsecond. Sorry, yeah.
Yes. So because this is in nanoseconds, whereas this one is microseconds. Micro means
Micro.
10 power minus 6, whereas nano means 10
Nine.
power minus 9.
Yeah.
So it's a lot faster. So when it comes to division, Python is better, surprisingly. NumPy is not. And let's apply it on reminder modulo.
Sir, then NumPy is a package, so it is written in a different language? Or?
Yeah, I will answer that. Yeah, I got your point. So basically, libraries need to be written in the same language, right? Python. So if it is being written internally using Python to simplify things, then it should not be more than Python.
Yes.
It should not be lot faster than Python. I think that's a valid question. I will answer that. So here division again is Python is 588 nanoseconds, whereas NumPy is better, isn't it? So only the division part is lot slower in the case of NumPy, right? The remaining operations like NumPy is definitely better. So only division part Python is better. NumPy has lost to Python. Now the question is, how come NumPy became faster than at least most of the operations? Faster than Python. Usually libraries will be written by the same language. When it comes to NumPy, they written it in C, C++. The library that we have imported, import NumPy as NP, the library that we get is simply a Python wrapper. In Python, that is possible. Even though it appears as if it's Python library, internally they may use C, C++. It's the wrapper on top of C, C++. That is the reason the operations that we see are not really Python operations. Internally, it is going to use C, C++. NumPy has that advantage compared to any other library. Even pandas, many libraries use NumPy, but NumPy is not faster, especially looping huge amount of data. NumPy is going to work very well, right? Any questions on this?
No, sir.
No, sir.
All right. So I hope you got an idea like how to create NumPy array and why we need NumPy. Like when we already have an option in Python, so what is the need of making things complex? So there is an advantage that it has been built using C, C++, right? So then we will move on to the next one. We already have myArray1 and myArray2. I'm going to utilize the same arrays. So here we have built-in methods like np add, right? So myArray1 1 by array 2. You can see that this will we can straight away use plus in between array 1 and array 2, but this will improve the readability. Subtraction. And do we have division? Divide we have. Do we have multiplication? 616, right? 616, 7 to 14. Yeah, we got the right values. What about, what else we have? Yeah, max, square root. Max is going to, it is not giving me the result because when we provide more than 1, you can see that we got 10 because see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What is the max value? 10. So out of these two, we got this one. So the same way we need to calculate the mean. What about square root? Square root of each value. You can see for each array, we got one value. It is two-dimensional, even though the original array is one-dimensional. Because this is for the first array and this for second array. And the next one is exponent. So if you want to apply exponent, e power whatever the value that we provide for the entire array is how we do that. This for the first array and this for the second. E power 1, e power 2, e power 3, e power 4, and so on and so forth. And okay, any questions up to here? I'm going to create. Yeah. I'm going to create an array. A random array. It has a bunch of values in it, right? Suppose you can see a lot of zeros here. If you want to remove, I mean, if you want to get only the non-zero values, there is a way to get it. Non-zero, to pass this array, what we get here is 1, 2, 3, 6, 8. Do you think that we got non-zero values? Compare these two values. What non-zero does is going to give us the non-zero values. It is not going to include zeros. Do you think that we got the value?
No, sir. 5 is missing.
5 is missing.
7, 7, 4.
Okay. What about 10, 11? So do we even have these values 10, 11 in this original array? What do you think it could be? So what do you think this could be? In fact, it is right. It's not that it is wrong. What do you think these values are?
Non-zero numbers means it is taking out the zeros and giving the
Giving
numbers.
any other number.
Yeah, but we haven't got that value, all the values. In fact, we got values that don't even exist in the original array.
10 and 11.
What do you think these values are then? These are not the actual values. I got it. What are these values then?
Maybe their memory locations kind of thing.
Index, right? Index.
Okay.
If you look at this non-zero values, it starts with 0, right? Index starts with 0. Of course, we have a 0 index value is 0. 1 index value is 1. So here the non-zero value is 1. The index is 1. Next non-index value, a non-zero value is non-zero index value is 2. We got 2. Non-zero index value 3. We got 3. But 4, 5, it has been skipped. And sixth value, the non-zero next value is 6, but the index is 6. 6. And again, 7 has been skipped. 8. Okay, the value is different, the index is different. Okay, so 8 again, we got 8. Index of 8 is 8. Index of 9 is 9. Index of 7 is 10. Index of 4 is 11. That is the reason we got indexes. So we can save it in this thing, variable, and we can pass it in square brackets to get the actual value. Now you can see 1, 3, 5, 6, 8, 974. All non-zero values. So what non-zero does is going to give us the non-zero index values, not the actual values. We need to store it in something and we need to get this. We can straight away copy this code. There's no harm, but it is going to increase the complexity. It is difficult to read. Rather, we can stick to this one, right? There's nothing wrong in using this one, having 2 lines of code. Absolutely fine. Okay, any questions on this?
No, sir.
No, sir.
The next one is random values. We are like when we declare some array, we are manually creating it, isn't it? We are manually writing all those values. So suppose if I want to create an numpy array, let's take np dot array. We want to write like 1, 2, 3, 4, 5, or maybe more. Let's take up to 10. I need to manually write it. Rather, we can use random to generate that. For example, let's take 1 comma 10. Maybe, 10. You can see we get random values. Random is going to generate random values, not in sequential manner. There is something called range. We will see that later. So there is something called a range to generate sequential values.
So first what you have written is generate 10 values of from 1 to 10, right?
Yeah, 1 to 10. Actually, it's not 1 to 10. The values what are the values that we get here? It's going to be in between 1 and 10.
In between, it will not include 1 and 10.
No, 10 will not get included, but it is between 1 and 10. Suppose if I have written, if I want to get even 10, sorry, it is 11, you can see the 10, but it may or may not occur.
Like yeah, x minus 1 it will be.
Yeah, the outer bound is not going to get included, and it may or may not get, you may get. So you may not get 10 also, because these are random values. So we are trying to generate random values in between 1 and 11. I mean, including 1, but excluding 11. Outer bound is not going to get included, but it's going to generate 10 values. But if you omit this part, it's going to assume that it is going to start with 0. So it may include, I mean, okay, in this case, when we have included this one, we got this thing. So, okay, now it may include 0. By default, it's going to be 0. For example, if you skip this part, then you will understand that even 0 is going to get included, right? So this is going to generate the random values, but if you need it in sequential manner, use arrange. But there are alternatives for this random. Let me give that one too. np dot random dot ran n. Let's take I need 100 values. You can see it is going to generate 100 values, right? So I need only 10 random values. I have 10 random values.
Why is it not like integer? It is getting in the float value. I mean, int we have to specify that.
Rand n, because it's going to give data. If you by default rand n is going to generate float values. If you need it in the form of int, we need to use the rand int.
Specify that. Yeah.
There are dedicated methods for it. The reason why it has generated float values, this can be plotted. For example, don't worry about the code. Yeah. Suppose if you pass this data, say that I want to plot it against, let's say, 100 values. You can see there is a plot here. So you can see almost normal distribution. Normal distribution means most of the values are going to be in and around average. The remaining, remaining values are going to be very less. And this part is very less. So most of the values are in and around average. That's the reason we got that one. I want to suppress the warnings. Is that we got average. When it comes to the same one, let me take the same code, and instead of this, I want to go with this one and int. Okay, I'm going to generate 100 values. 100. I think yeah. So you can see that it is uniform distribution. Do you see the difference? Uniform distribution is like 1, 1, 1, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, kind of. So if you look at the frequency, it is 3, 1, all ones are 3, right? All twos are 2, threes are 3. I think please mute yourself. There is a lot of noise. Sirisha, please mute yourself. All right, 5 is, we have 2. So when we plot a graph on these values, for example, we take a graph 1, 2, 3, 4, 5. And if you look at the frequency, this is just considered as the frequency. Then it's going to be 1 is 3, 2 is only 2. Maybe you can stop there. So just consider that 1. That's 1, 2, 3, right? Then 3 is again 3, right? And 4 is 3 again. 5 is only 2. So we get a uniform distribution. If we have values in this form, 1, 1, and 2, 2 kind of, then you're going to get a plot like this. So it will help us understand what is the distribution of the data, right? So if you ask me what is the difference between rand_n and rand_int, rand_int of course is going to give us the integers, and rand_n is going to give us some random values, but this n indicates normal form, normal in this bell curve. So most of the values that these rand_n generates, random values that it generates, are it's going to be in and around average. There is another one, np.random. Say, I don't know, 2 given. Okay, it just generate 10, right? So let's take that. Yeah, it's just like the way rand_n. I'm going to take the same thing as this. Try to plot a graph, right? Instead of rand_n, I'm going to replace with this one. So I will take generate 100 values so that I get a better plot. You can see that all these values are again kind of normal. Let's take 1000, maybe 10,000. So the values that it generate appears to be normal, but actually it is going to generate random values that are more uniform in nature. I hope you got an idea now. So,
Yes, yes.
right, this more normal form. So more and
So,
more.
I mean, is SNS, as you have written Seaborn, is it like a Tableau, which for
Yeah.
visualization?
Yes. So Tableau, it's not exactly like Tableau. Tableau is a tool, whereas Seaborn is a library. Of course, it's for visualization. The purpose is same.
So, will we use Tableau in this course or not
Yeah,
required?
we will have one project on Tableau, but this is not Tableau course. So this is more generative AI. So we'll stick most of the time. We will stick to Matplotlib and Seaborn. There will be one project in Tableau.
Okay.
So any questions on understanding the difference between random, rand_int, and rand_n? And of course, we have seen arrange also. If you want the data in sequential order.
Then, sir, NumPy is only for numerical data analysis. Means
Right, numerical data. Most of the data that we handle is numerical analysis. Right? Even we can store strings. It's not that we should not store strings. Even it's data for data analysis, but it is difficult to write the code. It's not as easy as it in pandas or any other library. It's more like core library, base
Can you
library.
please go back to that A rand?
Okay. You're not
Yeah,
saying
it's
and
like
it's a range.
sorry. A range. So the values will be always like increasing order and ascending.
Yes. For example, if I have 100, it's going to be in ascending order. We need to apply sorting in descending order on top of this. I think there is, I don't know whether it's step. No, there's no step.
Can we apply graph for this one, A range?
Of course, but it's sequential, right?
It will be like
Doesn't,
linear type.
yeah, it doesn't make any sense. So the reason why I have taken plots is to show the difference
For the
between
distribution of the values. Yeah,
random, random, and random.
got it.
Of course, all three gives the random values, but what is the difference between these three? Randint, of course, I can understand it's going to give integers. What about the other, right? So to answer that, I have explained it. Anyway, the next one is the floor and ceiling value. Python we discussed. Suppose if you have 5.2, what is the floor value for this,
5.
5,
right? So the same, what about ceiling value?
6,
6. It's always, what if we have 5.8? What will be the floor value?
5,
5. Same.
Same,
6.
right? What about round? 5.8?
6,
6. What if it is 5.2? What will be
5,
the round value? Yeah, it's 5.
5.
So you are clear about it. So if we have np dot flow to get floor value in NumPy, whereas np dot seal to get the ceiling value. So yeah. Anyway, you
So
know,
for round, if it is above 5.5, it will go around that one, right? 6 below means it will come to the 5. Is it that one round?
round is different. So round I have written only to explain the difference between floor, seal, and round.
I mean, how the round works? If it is more than 5.5, it will take it as 6
Right.
or something.
Yes.
yes,
Anything that is below 0.5, if it has decimal value, it's going to take the lower end value.
In NumPy, the seal doesn't work. It will get the same value as it is. No, it's
No, I think you got confused. Seal value is 5.2 is we got 6, right? We got the right value.
to get the same value to 5.
Floor value. So why do
The
you
floor
want
value.
floor value is 5 point?
Yeah,
Floor
okay, got it.
All right. So next one is SC type. SC types will give us the list of data types that NumPy supports. Someone asked, like, is it only for numeric analysis? No. We can even feed any kind of data type. As you can see, integers, unsigned integers, only the positive values, float, complex, object will string. All strings will fall under object. Suppose if I create numpy array, right? That's 1, 2, my string, right? 4, 5. If you check data, it's saying something like U11. You can even dictate data type, D type, str. Let's see. You can see U9. Maybe I can say np dot object, or maybe simply object. Now you got the object. So usually strings, if we have string over and we have other values like number, integers, floats, and all, string usually have more higher precedence. Suppose even let me include 4.5. So it's still object, or maybe even if you skip this U11, U9 and all led to strings and objects. So you got, this will have more precedence. If we have, let's take 4.5, then if you check this, let's take, what is the data type? This my array. Oh, D type, if you check D type, you can see float 64. So even though it has integers, the float will have higher precedence. So that's the reason it comes with float 64. We can enforce this data type. For example, in 32 something, right? Then you can see in 32, but the way array is going to get changed. This 4.5 is not anymore 4.5. It has removed the decimal part, isn't it? It has converted to integer.
So which has the highest preference?
Obviously, objects will have higher preference.
Oh.
And we can even have, let's take complex number, j, but we can't enforce it like it's going to lose the data. You see that it is converting all the numbers to complex numbers. You can 0j, right? 2 has been converted to 0j. So we can do that. But it's always better to have one set of, usually it comes all from a column, right? Each column. Then in that case, it's better to have one data type. But here we are trying it, so I'm trying to give all sorts of combinations. And as I said before, we can specifically mention the data type. For example, in this case, let's take in 32. If oh sorry, E is missing. What is missing? So, okay, he's saying that real number not complex, right? So that's the reason we got that. If we have a string, I think that's the same case. But if we have a float, it automatically converts. Fine. So we have these things in 32. Right now, if we check data type, it is in 32. We can convert it into another data. For example, in this case, 8, int 8, 16, 32, 64. So 64 in this is going to occupy 64 bits. It's going to occupy more space. But the advantage of in 64 is we can have larger values, like in billions. But in 32 is going to have less capacity compared to 64. We can't give as large as it in 64. So, but when we have smaller values, when the range is small, then it's better to use a smaller thing because it's going to occupy less space. Suppose if I want to convert this in 32 whatever to another data type, we have something called as type. So we know how to dictate a particular data type to while declaring itself. What if I want to convert it? For example, I want to convert this into np dot float 64. We can convert it. Now let's take int. I don't because the values are very small, so I can stick to np int 8. You can see that it is int 8. Of course, we need to assign it back to change the behavior. If you look at this int 4d type, you can see int 8 only. This is going to occupy less space. Unless you are like you want, there is a possibility that you may have larger values. Always better to stick with the low end configurations, int 8 or whatever, you int 8. Complex 64, complex 128 is obviously you need to choose complex 64 if it is less in size. I mean, if the numbers are not large. Any questions on this?
So the default int will be int 8 itself.
The default is not int 8. If you look at this data set, let me remove the decimal part. 4 and 32.
Okay.
Based on the data we provide, it's going to come with, but it's not always maybe the intended one. So if we need a much, in this case, we can go for int 8 because we don't really require int 32. Disadvantage is going to occupy lot more space, right? Anyway, so any questions on that? You have seen how to clear, how to declare a variable with d type, how to check data type, and how to convert from one data type to another data after it got declared. So, any questions on that?
No.
Yes.
Next one is, do you know matrix multiplication? I think you might have done it in school days. Let me create numpy array. Do you remember it? No, that's the question. One is responding.
Yes,
Has
sir.
compared
That
to yeah.
long back.
Okay, you may not remember the formula, right? That's fine.
Yes.
The
But
rows, columns, yeah.
what will happen if we apply this?
Most probably 1 into 3 and 2 into 6.
Yeah, you're speaking the matrix multiplication, right? But if you look at these values, what do you think has happened? So do you really think that it is a matrix multiplication?
No.
No.
Because its corresponding index value has been multiplied. 1 multiplied by 4, 2 multiplied by 5 is 10, 3 multiplied by 6 is 18, and 4 multiplied by 7 is 28. So by default, multiplication does not do matrix multiplication. So what we can do is, I'm going to mention as 3. Instead of array, you have other option, matrix. So by default, it's going to consider as array, not matrix. The same way, I'm going to 4. And if you look at this, it is 16, 19, 36, 43. Instead of calculating it, okay, we can calculate it. 1 multiplied by 3 plus 2 multiplied by 6, right? 3 plus 12. 3 plus 12, is it 1 multiplied by 3 plus 2 multiplied by 6, right? 3 plus 12. 3 plus
15.
3 plus 12, 15, right? So what we got here is, why we got this one? Okay. 16 we got. Uh, why do you think that we got this one? It's okay. So let's my array 4 is 1 multiple. Okay, sorry. It's actually this one, right? So we are 1 multiple, we are calculating the same array. So 1 multiplied by 4 plus 2 multiplied by 6. So to 1 multiplied by 4 is
Plus
4
4.
plus 2 multiplied is 12. So 12 plus 4 is 16. So that's the reason we got 16. The same way for other values too, right? 1 multiplied by 5 plus 2 multiplied by 7. So 5 plus 14, 19. We got 19. So on and so forth. So we need to explicitly write it like matrix to get matrix multiplication. Otherwise, there is an alternative way to do this. My array 1, my array 2 are normal arrays, right? There is something called np dot. You can see got the same result on numpy arrays. These are normal numpy arrays. And array 3 and array 4 are matrix arrays. You can see that we got the same result. So we can
If you
either
are using
use
the
dot.
normal array, we should use the dot function, or else we have to write it as np dot matrix.
Yes, we need to explicitly write it as matrix. Otherwise, it doesn't work the way that we expect. Right? Any questions? All right, we'll continue tomorrow. We'll stop it right now, even though we have 9 more minutes. We'll continue tomorrow. So we'll start back with broadcasting. Right? Any questions in today's session? I don't know whether now scripts are not shared, right? So please share your email IDs.
Here in the chat itself, or
Yeah, chat itself.
group chat itself.
So a Google Classroom invitation will be received to your inbox. Maybe in an hour or two by evening, you can cross check it. All the scripts will be shared over there. I will attach a PDF also. So how to navigate to this thing. So I will copy that in WhatsApp. So that you will get an idea how to interact with Google Classroom. Right? Yeah. So
Sir, I shared my email.
or Narayan, right? Yeah, two more. So
Yeah, shared it.
Sir, I also shared it.
I can see only two email IDs, Narayan and Sirisha. What about others?
Sir, I shared. Okay.
In chat. I need chat.
Change the pointing address. Maybe by default it's going to Ashok IT.
Right. It is going to
No,
Ashok.
so thing is, okay, this one you are speaking about. Okay, now anyway, Piyush, I got it. I think one more should be there, right? Piyush, Narayan, Sirisha, and who else?
Sir, Bharat didn't join today. One more guy.
All right. So I'll speak to him tomorrow. So you will receive an email in short while, maybe by evening you'll definitely receive it. And in case you don't see it in your inbox, check spam. Okay.
Oh,
Wherein I will share it in Google Classroom. So it is going to be like this. So once you have access to it, it's going to appear in this form, in this way. You'll have one of the cards, 7:30 or 9 a.m. In your case, January 9 a.m. So once you have this card, you need to click on this, and you need to click on classwork, wherein you will see the scripts. You can download it directly. Okay. So from here, you can download scripts from now on. And NumPy, I think I haven't uploaded, so I will upload it now.
Okay, sir.
And there are some size limitations in the Ashok IT website, so I have to upload it here. All right, that's it for today. So we'll meet tomorrow.
Thank you, sir.
Okay, sir. Thank you.